All right. We talked what? Square, triangle. Why can't we go to pentagon, hexagon, and all the way up, right? We should be able to find the area of those. And the answer says we can, but only if they're regular. Anybody, little recap, vocabulary review, going to the Regents in a couple months, vote regular polygon. Hi, Tammy.
So I think all sides are congruent.
All sides are congruent in a regular polygon, correct. That's the only type that we can find the area of. If it's not regular, we're going to have a tough time. I also want to reintroduce a vocabulary term we had from the circle unit that also can be applied to polygons. And you probably never knew this. These dashed lines I have up here that start at the center and draw into a vertice, just like a circle. What do you think I call that? It's a radius. Yeah, you can have a radius in polygons. Starts at the center and goes to one of the vertices. Absolutely. And just like a circle, what do you think I know about all those radii? They're all congruent. Correct. I hate writing sideways. Radius, and they're all congruent to each other. So my first question, what type of triangles did I form here in this hexagon? Isosceles, and I'm going to add in a more detail. What do you know about all six? Side, side, side. They're all congruent. All right, so the types of triangles we form by drawing in all the radii to the vertices, we end up making congruent isosceles triangles. So how would I find the area of this hexagon? You guys know the area formula for a triangle? Yeah? What is it?
1/2 base.
1/2 base times height. And in this case, how many triangles are there?
6.
And they're all congruent, so all the areas should be equal. So here's how I'm going to have you guys find the area of any regular polygon today and Monday. You're going to take the number of triangles in the figure and multiply it by 1/2 BH. Make sense? I'm going to see how many triangles I could get. They're all equal. I'm going to find the area of one of them and we'll multiply it by how many there are. There should be a short note today, and then I'm hoping, crossing my fingers, you guys get out of here with no homework. You ready? Mahmood, what's your deal already?
Could you also make it into a trapezoid? Do you have formula for trapezoid times 2?
A trapezoid. Yes. You would just have to find the height somehow, and that might be a problem. Okay, but yes, you could. All right, I like the idea. The only thing I worry about is when you draw in the height, I'm not too sure based on the information how you would find that height. Okay, I'm going to go out of order. Hopefully you're all right with that. If you're not, too bad. Can I start with the hexagon question number 2? I like to start with that one just so you guys get an idea of what's going on. All right, so I got a regular hexagon. Oh, you're welcome. Leave your answer in simplest radical form and a decimal rounded to the nearest tenth. So 2 answers, simplest radical and decimal. How many, if I draw in all the radii to all vertices, how many triangles am I making? 6? Everyone agree? I'm making 6. I don't need to draw all of them in, but I'm going to make 6 of them. They're all the same area. So multiply it by 1/2 BH. I have already drawn in one of those triangles. Help me find the area of it. And also, you're welcome. What do you already know for that triangle? I threw a 3 meters on there. What do you guys already know? Shoot. Think I can do? I'm going to do it. And hopefully it's annoying to you. Don't care. I'll go forever. But I want to do the homework. I don't care. Let's keep grinding. 4! Here we go, Griff. 3 meters for the base. Good. 3 meters is the base. So I can at least plug in 6 times 1/2 times 3 times. All right, I need your help with the height. Need your help with the height. BD. How do I find the length of BD? All right, let me go back to my diagram here. Remember, these were all congruent triangles, right? So shouldn't their central angles all be equal too? Everyone agrees? Can you find one of them for me? Come on, think, dig deep. How many degrees are going to be in one of those central angles right there for this hexagon? Come on, dig deep, dig deep. What's one angle going to be? Oh boy, here we go. I'm going to get annoyed here in a second. 17?
60.
60, how'd you find it?
360 divided by 6.
Good, so this whole angle here is 60 degrees. And we could get into why, but guess what? When I draw the height in, what do you think you know about these two new triangles you formed? They're going to be congruent. So that 60 gets cut in half by the height. So now, what type of triangle am I working with? That's a 30. That's a 60, right? And what happens to the 3? If those two triangles are congruent, what happens to the 3? Gets cut in half. So now I have 1.5, right? We already wrote the rules down. I'm not going to write them again. Where's the 1.5? Shorter, longer, or the hypotenuse? The 1.5. Shorter, longer, hypotenuse. 20, no. 55, 47, 45, 15. Shorter, longer, or hypotenuse? The 1.5.
Shorter.
Shorter, because it's across from the 30. Where's the height? Is that the hypotenuse here or the longer leg? Where's the height? All right, I'm done playing around. I gotta get moving. Where's the height? 23. Where's the height? Longer or hypotenuse? Longer. What's the rule? I got the shorter, need the longer. What's the rule? 10.
The shortest side times radical 3.
So what's my height going to be?
1.5 radical 3.
There you go. There's 6 triangles just like that. Let's first start simplest radical form. What radical will be in our answer up here? What radical will be on our answer? Radical 3. You're multiplying every other number now. Okay, radical 3 is on our answer. You're multiplying every other number. And what's that end up being? What radical 3 here when you're ready? 24?
Oh, wait.
3?
Okay, wait. 6. Which is 18. And then 5 by 2. It's not it.
It is.
Actually, I did. Hold on, I made a mistake.
You have a calculator in your possession right now.
That is correct.
Nobody needs your steps. Type it in your calculator. You're like reporting back to Quan, like 6, and then I'm pressing that X button,
Yeah, I know that.
and then I'm doing a half. You better get them together, Caitlin. Because new rankings are coming out on Monday, and this is not good for this group.
Oh my god. Okay. Good.
Should have kept this in the group.
People's IQs are declining right now because of this moment we're going through in this class.
Okay. So when I multiplied everything, I got 13.5.
Thank you.
Is that what you wanted?
Thank you.
Oh.
Whoa.
Bro, my multiplication, like, I forgot to stick it.
And then, yes, I'm going to get rid of this next year, but also as a decimal rounded to the nearest tenth, I'm afraid now. Also leave it as a decimal rounded to the nearest tenth. When you're ready for that, please no. 12, please help. Brendan.
23.4.
Thank you. Would you like to tell us how you calculated that, or are you good?
I multiplied them.
Okay. Yeah. Pretty much what you do. Yeah, you multiply. Good job. All right, any questions on finding the hexagon? Yes, it will end up being a 30, 60, 90 triangle every time. All good? Regular hexagon? All right, what about a equilateral triangle? I do not want to push you away. If you still want to do this, since it's a triangle, area equals 1/2 base times height, and go at it, draw in your height. Find it, find your base. You can still do that. I'm just showing you an alternative method today. Because it's equilateral, I can break this up into how many triangles? 3, which are all congruent. So if you just wanted to use this formula on the full triangle, you could. I'm going to use the alternative way because that's today's topic. I'm going to take the area of all 3 and area of one of them and multiply it by 3. Everyone see your different options. Just take the full triangle. If you can get the base and the height, go ahead. Or if you want to break it up into 3 like we're going to do right now and find the area of 1, let's go. Can anybody find that angle for me? Because I'm about to cut it in half when I draw the height. You guys are going to help me find the area of this highlighted triangle right now. That's what you're going to help me find it. What's the area of that highlighted triangle? What's the angle up top? Angle up top right here. Need to know that angle. They're all congruent, remember. 12 again, little help.
60.
Not yet. Not yet. You're going to step ahead of me. The full angle, Brennan. Full angle. I haven't done anything to it yet. You got 3 of them here, right? That are all equal. 3 of them? Yep. Go ahead. Recalculate. It's all right.
120.
Everyone 120? Everyone's all right that this full angle is 120. Draw the height in. Draw the height in for that triangle. What happened to that 120? Just got cut in half. So everyone see now I'm going to have a 60 here and a 30 down here. You ready? Yes, Serena.
So you said we could do it without like splitting into 3
Yep.
triangles. How would you find the angles then? So
How would you find?
Like, because you need to get it to 30, 60, 90.
Okay, let me go over that at the end. I'll do the same exact thing, but do it on just the regular big one. Okay. Where's the 4? Opposite. Yeah, opposite. Hypotenuse. See, that's what happens. I listen to Mahmood and just the quality of teaching just goes way down.
Wait, what?
Yeah, you heard
so
me.
mean.
You heard me.
I don't fucking know. Come on. Like, what did I do? I forgot to multiply 1.5 because.
Don't start up again. Don't start up again. We finally got out of this vortex. Don't throw us back in.
Alright, my bad.
Don't throw us back in.
Forget that.
4. Shorter, longer, or hypotenuse? Shorter, longer, or hypotenuse? 6. Hypotenuse. Can you guys get to me the side across from 30? Do we have to write the rules again? Hypotenuse equals shorter leg times 2. Longer leg equals shorter leg times radical 3. So if my hypotenuse is 4, what's my shorter leg? 8. 2, which would be my height. 2. And what's the side across from 60 now? Longer leg would be 20. Longer leg. Follow-up question, Jonathan. Is that what I want to plug in for base here? Is that the length of the base of my highlighted triangle here? 2 radical 3? Good, because the other half is 2 radical 3, and you know how to add radicals. So the base would be 4 radical 3. Radical 3 in your answer. This is just simplest radical form. 17, when you're ready, simplest radical form with the radical 3.
12 radical 3.
It is 12?
Yeah. Yeah. Because like
Okay, I have a mistake on it.
Oh!
Don't even start! Don't start with me right now! Don't start with me! All right, don't start with me.
What did you have up?
Don't start with me.
You have a calculator machine.
Oh, don't even start.
Just Carlina pulled that
All right, yeah, all right, we're good. Yep. Karma, I know, karma.
Well
Yep.
deserved.
Karma.
Yeah, that's right. That's bad.
All right, I'm not even going to tell you what I've written down on my paper. But it was wrong. It was wrong. All right, sorry. It was wrong. Questions? All right, going back to Serena's question. Yes, you could break it up into 3, or you could just take a look. Let me go through it real quick. You could just find the area of that triangle right there using 1/2 base times height. So let me draw in the height. Good so far? You okay, Serena, on how I know that's 4? It's a radius.
Yeah.
Good. And we know what type of triangle is this? The whole thing. The whole the triangle we're finding the area of is what type of triangle?
Oh, just kidding. I calculated. Sorry. Equilateral.
Equilateral.
Got it.
What do we know about anybody? What do we know the angle measures are in an equilateral? 60, 60, 60, right? This radius that was already drawn in for us is cutting that in half. So this is going to be 30,
Oh, okay.
60, and we're kind of back to where we were.
Yeah.
So if that's 4, that's 2. Height of 6 now, right? And your base, 4 radical 3. 1/2 of 24. 12 radical 3. So we could still do it that way. Okay? Other questions? Going? I am going to change the last problem, which is the square. Ooh, 2 genies. I know. I say it all year long. What class are we in? Honors. So the highest of expectations. But the algebra that would be involved in this, if I left that 7, is just way above and beyond what I would ever expect of you. All right. So I'm going to change this from 7 to 7 radical 2 centimeters. Okay. 7 radical 2 centimeters. It's a square. What's the area formula for a square? Base times height, length times width. So again, I'm not going to discredit that. If you want to use that, that's fine. I'm going to do it the alternate method we're showing today, which is how many triangles can I break a square up into? How many congruent triangles anyway? 4 of them, right? Draw them each vertice, I get 4. So I'm going to do 4 times the area of one of the triangles like I've been doing all day today. All right, same thing. You guys find me this full angle here formed by the 2 radii? Because I hate to break it to you, it's not going to be 30-60 combo here. What's that full angle there? The full angle I just drew in there. 6? 90. Yep, 360 divided by 4. That's 90. So everybody right now, draw in your height. And what just happened to that 90? Cut in half, so now I have what type of triangle? Our other friend, the 45, 45, 90. Okay? Ooh, but a little change up here. What is the 7 radical 2? Is that one of the congruent legs or the hypotenuse? Is that the hypotenuse or one of the congruent legs? 19, which one did I give you there? Ooh, yeah, I don't like when I start with the hypotenuse. What was the rule, by the way? Hypotenuse equals what in a 30, 45, 45, 90? Leg times radical 2. So if the hypotenuse is 7 radical 2, what's each leg going to be then? What do you think? What's going to be each leg then? The hypotenuse is 7 radical 2. The leg will, each leg will be, oh boy, 22s, 2s. Yeah. Is that a question or an answer? Answer. It would be 7. Yep. 7, 7. All right, go back up to my formula. Area equals 4 times 1/2. Can somebody fill in the base and the height of that triangle now? Eva, ready? I will relax. I'll start off with the easier one. What's the height? Yes. Base? How'd you get 14? There you go. Base of 14. $98 square units. Do we got any units on this one? Centimeters. And look, if you wanted to do length times width from the beginning, 14 times 14 times. Wait, 14 times 14 is not 98 though, is it?
It's 196.
Twice in a row.
No, it's not even.
Twice in a row.
That's even worse.
I'm not even going to make excuses because I had the 7 radical 2. I had the 7 centimeter work on my paper, and that answer was 98. But all right, nope, no excuses, right? No excuses in this class. 196. So fired up. I made those mistakes. Anything else? I think it's time for me to quit right here. I'm good for today. You guys could start the 4 or 5 problems that are assigned in the book. Plenty of time. Use whatever method you want. If you want to break it up into triangles, that's fine. If you just rather use the original formula, that's fine.
No, I won't.